Good morning. We have Q4 week 4 day 3, and we'll get right at it here. This day is probably the hardest of the week, I think. So let's go ahead and complete the square here. We have x squared plus 2x plus 9, and so we're going to see if this fits. So half of this first coefficient a has to be a 1 to complete the square, just to keep that in mind. If it's not, you got to make it that by dividing. So c value is supposed to be half of 2 and squared it. So it's going to be 1. Okay. So then we can just take this equation using our little shortcut that we've learned this week. All right. And we can put the number in that it's supposed to be. We'll set this other one off to the side. Okay, and we're going to put that 1 in here. And we're also going to put a minus 1 right here, which is really adding 0 if you think about it. And then we can factor and we'll be done. So square root of that is x, square root of that is 1. Add a positive between them. And so we don't even need to throw that equals 0 in here anymore. So plus 8. And there is your vertex form. Okay. Alright, continuing on. Quadratic equation to solve. I wanted to show you this one primarily because of the negative discriminant that we're going to get on this and get some imaginary numbers. So try to do a little better job of explaining that. So we've got an a value here of 2. Okay. I'm actually going to move this thing over to the other side technically. Everything the opposite of what it is. Put the 0 on the right. So when you do that, moving everything, all it does is going to make your sign the opposite of what it was. Because technically the quadratic equation is supposed to be used in this form. If not, your signs will be backwards. Okay. As long as you remember that, you'll be okay. All right. So that gives me an a value of -2, a b value of -6, and a c value of -5. Okay. All right. So let's go ahead and attack this thing. So x is equal to -b, so negative and -6 plus or minus the square root of b squared, so -6 squared, minus 4 times a times c, all divided by 2a, so -2. Alright, that, and then we got some simplifying here to do, so we get -6 plus or minus 36 and -40. So 36, -40, -4. So that's going to leave you with a negative discriminant right here. So we're going to get an imaginary number for this. Normally we would have just stopped, but we might as well continue to learn. That's the whole point here, taking you beyond what we're supposed to do here in regular algebra. So that's going to give us the square root of -4, all divided by -4. Okay. Now I need to pause here just for a second. I want you to think. We haven't really dealt with this very much. When we do square roots, we want to look for perfect squares that are inside of that. Now this 4 happens to be a perfect square factor, so it's going to come out, the square root of 4 is just going to be plus or minus 2. But that negative means it's impossible. There's nothing that I can multiply together to get negative 4. So we had to create these imaginary numbers to do that. Okay? So when we did that, we basically just said, well, this is going to be a negative 1 times a 4. And we're going to do the parts that we can do. So this square root of 4 is possible. So that's going to come out, and that's going to be our 2. All right, so we're going to have negative 6 plus or minus 2. And then we created the imaginary part, the square root of negative 1. We turned the square root of negative 1 into the letter I, meaning imaginary. So all you have to do is you can factor out the square root of negative 1 anytime as the letter I, and then we just simplify the rest of this equation. Okay? All of these are divisible by 2. Okay, if you want to keep it in one improper fraction like this, or you can separate it into separate equations. I'm just going to divide everything by 2 or by negative 2 in the case of this problem. And so if I divide everything by 2, I'm going to get negative 3 plus or minus 2i. That's not what's going to happen. I'm going to get negative 3 plus or minus I, all divided by negative 2. Okay. And, oh, where did I lose my sign at? In here somewhere. Of course, I screwed that sign up a long time ago. Back here is where I see it. This should be a plus. There we go. So, good thing it's an easy fix. Wouldn't want to have to make a whole video again for that. Alright, so that's going to give me 3 plus or minus I divided by negative 2, or, depends on where you put the negative, I can also have negative 3 plus or minus I over 2, which is B. Alright, get that ugly guy out of there. Alright, continuing on, we got area and square feet of 50. So I'm going to start with area, length times width. You guys may go about doing this a different way, but I'm going to attack it algebraically. So we've got 50 is equal to x minus 3 times x plus 2. Okay. We could definitely substitute these in and out, in and out, in and out, using our 3rd and 4th grade strategies there. That's a great job. They work a lot of times, but I'm going to go ahead and practice using my algebra skills so that I can get ready for algebra 2 and geometry. All right, so we got x squared, and then we have 2x, and we have negative 3x, and finally negative 3 and 2 makes negative 6. Right. Clean that up a little bit. Go ahead and start, make this 0. Skip a step here, and we're going to get x squared. These combine together to make minus 1x. And then 50 comes over here and becomes negative 56. All right, and this is factorable. So x, and it's going to be 7 and 8 is what we're going to be working on here, and I need to be a negative 8 and a positive 7. I'll take a check just to make sure that's what I want before I get too much farther. That gives me negative 56. Negative 8 added to 7 gives me negative 1. Yep, we're good to go. So I get x values of 8 and negative 7. right, so I just got to plug that back in. The -7 doesn't work because that would give me negative values right in here. So the 8 is what I want. So 8 minus 3 gives me a side length of 5. And then the other one gives me a side length of 10. And that's 15 doubled. So add those together. 30. Okay, could have went all algebraic-y on the second part too, but there's no reason. Okay, so perimeter of 30. All right, and then on to the piecewise function. Remember, piecewise functions are just a way to show different things that are occurring in the same situation. So maybe at a certain temperature, nothing happens, or at a certain pressure. Think of maybe a rocket, for example. We have to get to a certain pressure, a certain amount of force for that rocket to leave the ground. In the case of that, or like this here, for example, would be maybe, this is not a great example, but if you look at this graph, we have something that's remaining constant, remaining constant, remaining constant, no growth at all, and then all of a sudden it instantaneously decreases significantly, and then it increases significantly. So this may be, it's not a great example, like I said, but maybe like your hair. Your hair is barely growing. It's just so long. It's barely growing. Let's call it not growing. And then you chop it off, and then it starts to grow. Okay. Or this could be, it couldn't be a growth spurt because then you have to chop your legs off or something. But anyways, let's continue on. So what happens is we just have the rules within one. So instead of writing this separate, we say, all right, if our x values are greater than or equal to -2. Okay. So that's going to be starting right here. Here's -2. And if they're greater than that, we're going to follow this function. Okay. But if we're talking about x's that are less than -2, so right here's the -2, anything this way, we're going to follow this function, which is just y equals 6, this horizontal line. So let's take a look and see if it's following those rules. Anything less than -2, so we have an open circle on -2. We're going to follow y equals 6. Yep, that's good. And then starting with -2, we are going to follow this one here, which has a slope of 3 and a y-intercept of 3, 1, 2, 3, and 1, 2, 3 over 1. Yep, so this is a true. Okay, no work really on that one. I'm going to continue on. Use the function to complete the operation. Yeah, I'm going to make our life easy here. Multiply these together all you want, and then multiply by 0, you're getting 0. Okay, so don't waste your time there. And we're going to add these together. Let's just stack them. I don't even know what number I'm on right now. What is that? Adding them together. Number 6. Okay. All right, so 6, we have -10 and 1/2 makes us have -9.5 x, and then -13. Okay. Continuing on. Subtracting them now, so we're going to do in a different order here. So these signs are going to go opposite. Nope, these ones are, because this is what's happening there. So we're going to take our g of x, okay, minus 6. There's our g of x, and we are going to be subtracting this entire quantity. So don't lose those signs here, okay? All right, so this is going to be a negative, and this is going to turn into a positive. So -10x minus 6 minus a half x, and then plus 7. Awesome. So this here gives me -10.5. Okay, and positive 1. Okay, which is going to be the none of the above. Somebody lost a negative in there, so And lastly, a bunch of multiplying here. So number 8, -6 and -7 makes 42. -6 and times a half makes -3x. -10 and -7 is +70 x. And then half of 10, -10 is -5 x squared. And you put it in the right order, we end up with, let's combine these right here, so we get 67x -5x squared. Most of you probably did that first to jump a little bit out of it, and then +42. So what do we get there? I get none of the above again. Oops, excuse me. All right, you guys have a good day.